Hi class, this short lecture video is on enzymes. Okay, so up front we're just going to define what an enzyme is, and we've seen, again, just like ATP, we've seen this word or time or two come up through what we've studied. So enzymes are going to be proteins that help chemical reactions. Proteins that help chemical reactions. And I want to tell you real quick the idea of helping. You know, the technical name would be catalyze, which is actually used in your textbook, but I'm not that concerned with using that term for this. But I thought I'd just tell you, like, what's it really mean to help a chemical reaction? So there's a couple of things that these enzymes can do to help a chemical reaction. First is it can make it use less energy. Right, so for efficiency, that's good, right? We don't want to use energy if we don't have to, so the enzymes would make it so that we're doing the same chemical reaction with less energy. And then enzymes will also speed up reactions. Again, an efficiency thing, right? That's what both of these things we're kind of using to mean help. That's all about efficiency. Right? Use less energy, make it happen faster. Those are pretty important aspects of what enzymes are doing. All right, and then I want to tell you just a couple basic things about enzyme structure and one or two things about how they're working. Right, so enzymes will bind chemicals called substrates. They will bind chemicals called substrates. And that binding happens at a specific part of the enzyme that's going to have a specific shape. So it kind of look like this. So this box that I drew is our enzyme. Okay, so the substrate would have to match this little indented site that I drew. So our substrate would have to look like this, and it would come in and fit in that little space, right? So what I drew in orange is our substrate. It'll come in and attach to the enzyme at this little shape, this little indentation that I drew in the enzyme. Hey, that little space, it's called the active site. And that active site is always where the substrate comes in and attaches to. Right? So these enzymes are binding substrates at the active site. And then I know this is kind of stupid to show you, but you know, think about the shape of the orange substrate we drew. It matches the active site. Now, if I drew a different, if I just got rid of everything so we can't see it anymore, if I drew a different substrate that looked like this, we can just call it substrate number 2. You know, do you think that would fit into the active site? All right, if we have the same enzyme that has the same shaped active site, this substrate 2 isn't going to be able to fit in that active site. Right? So enzymes are very specific to substrates. Almost always it's one substrate that can come in and attach to an enzyme. All right, and then I want to tell you that, again, for efficiency, enzyme molecules are not used up. Right? If we think about these as being involved in chemical reactions, it's easy to think that enzymes are going to get used up. But enzymes are functioning in cycles. The enzymes are in cycles. So here's our enzyme again. It's going to bind a substrate and then release the substrate as products and then come back and get used again. It's just a cycle. So, you know, we'd have substrates that we're adding in here. We'd have products that we're pulling out over here, but the enzyme itself is not changed. And one enzyme molecule just gets reused over and over and over and over. So again, efficiency. These are really efficient proteins, really efficient catalyst. All right, so that's what I wanted to talk to you about with enzymes. When we head into cellular respiration and photosynthesis, lots of enzyme catalyzation going on with that. So basically every step along the way is going to be catalyzed by enzymes.